All right, for 12.4, we're going to be looking at logarithm functions. And we use this when we're going to be solving when the variable, when the letter is, like for example, I can ask you guys something simple that we covered in the previous sections. 2 to the x is equal to 8. Now you guys can find out that x is equal to 3, right? Because 2 to the third is equal to 8. But what if I gave you 2 to the x is equal to 9? And I'm asking which decimal power is it such that 2 to the x is equal to 9? Now, this is when logarithm is very important. One thing I want you guys to notice though, I'm going to call this the y is equal to logarithm base a. Notice I'm calling this little a, I'm calling it base a of x. So that's how you read that. Y equals log base a of x. The way we can rewrite that is x is equal to a to the y. Notice how here, remember in exponent, the number at the bottom we call it base. Notice how it is the same letter. So once again, in exponents, the number at the bottom, the big number, base, in logarithm, we call it log base a of x. And then here by itself, sometimes on the left side of the equal sign, sometimes on the right side, here by itself, I have an x. Here I have this. So the exponent, it's right here as well. My exponent, and notice how here my exponent by itself. Remember I said logarithm was how we were going to solve for the exponent. So it makes sense that we have the exponent by itself. A logarithm, I'm just going to read this right here at the bottom. A logarithm is an exponent. The expression log base a of x represents the exponent to which the base a must be raised to obtain x. Let's take a look at this in work. For example, convert between exponential and logarithm form. So for the first part, I gave it to you in exponential form. Remember, the 3 is the base. The exponent in here is 2. So I'm just going to write log base of 3 of 9 is equal to 2. What I have by itself, in this case on the right side of the equal sign, is the exponent. So remember, once again, I have to let this equal to the exponent. So I call it log base of 3 of 9. Log base 3 of 9 is equal to 2. Let me skip to this other example. I have 10 to the 5th, right? 10 is the exponent. 10 is the base. 5 is the exponent. So you guys might be thinking, all right, for sure, I have to let this equal to 5. I have to let this equal the exponent, right? The base is 10, so I'm just going to say log base 10 of 100,000 is equal to 5. Now, let's take a look at these two examples. I gave you some examples in logarithm form, and I want you guys to write it in exponential form. So I'm just going to say, well, the base is 1/5. So I'm going to write this as 1/5 to the negative 2 is equal to 25. The other example, I'm going to write this as 4 to the negative 3 is equal to 1/64. Now, this is for you guys to try some at home. I gave you guys in exponential form. I want it in logarithm form. I also give it to you in logarithm form. I want it in exponential form. And that is basically what you guys will be getting. Now, let's actually solve for them. We're going to learn these how to solve. So first, let me rewrite everything in exponential form. Remember here I have the basis 4, the exponent is -2. So I'm going to rewrite this as 4 to the -2 is equal to x. And I get my x from right here. I have 4 to the -2. I know 4 to the second is 16. So 4 to the -2 will be 1 over 16. Remember the negative, what it does is it does the reciprocal. So 4 to the second is 16. 4 to the -2 will be 1 over 16. So I have that 1 over 16 is x. I already solved for x. Let me rewrite example B in exponential form. I'm going to write this as x to the second. Remember, that's my base. That's my exponent. So that's why I wrote this as x to the second is equal to 3. And you guys can see where I got my 3 from. Now I have my x, and I'm thinking, how can I get my x by itself? There's a second power. How can I undo an exponent? Well, I'm going to do the square root of it. So I'm going to have that x is equal to plus or minus radical 3. All right, let's take a look at example C. Let me write this in exponential form first. So I have 1/2 to the second powered is equal to 3x plus 1. I know 1/2 to the second power, this and that 1/4. So I have 1/4 is equal to 3x plus 1. For the plus 1, let me move it over as a -1. But instead of just writing 1, I'm going to write this as 4 over 4. Right? My -1, I wrote it as minus 4 over 4. Why? Because I have that -3/4 is equal to 3x. For space purposes, let me rewrite that over here. -3 over 4 is equal to 3x. All right, I have to divide by 3 because I have to get the x by itself. So I have -3 over 4. It's equal to x, right? Notice I just rewrote my question, 3x. But I said I'm going to divide by 3. When we divide, don't we just put the 3 at the bottom of the fraction? So let me just put my 3 at the bottom of the fraction. That way these 3's cancel out. These 3's cancel out. So I have that x is equal to -1 over 4. Nice. Once again, for division, I just wrote my 3 at the bottom. It cancel out, so that made it easier. Now this is for you guys to try at home. That's exactly what you guys will be getting. Now let's practice a couple rules. Log base 7 of 7 equals something. As a matter of fact, for right now, I don't know what it is. There's a formula. I don't want to give you guys just the formula. Let me call it x for right now. I'm defining what this formula means. So based on what I know, I have 7 to the x. So let me write this as 7 to the x is equal to 7. Now 7, the one that I have by itself after the equal sign, can I just write it as 7 to the 1? So I have that 7 to the x is equal to the 7 to the 1. Remember in previous sections, we said if the bases are equal, in this case, the bases are equal, let the exponents equal each other. So I'm going to say x is equal to 1. So let me cancel my x. And I'm just going to say log base 7 of 7 is equal to 1. Now let me introduce you guys to a rule. Log base b of b is equal to 1. When these two numbers are the same thing, my logarithm will be equal to 1. So let's take a look at example B. log base 2 of base log base radical 2 of radical 2. Notice how those two are equal to each other. So based on this rule, I'm just going to say 1. I'm not going to work it all the way out. Now let's take a look at example C. There's another rule. I don't know what this is equal to at the moment. So I'm just going to say that 9 to the x is equal to 1. Now, an exponent equal to 1, 9 to the x, can I just rewrite this as 9 to the 0 is equal to 1? I know anything to the 0 power is 1. As a matter of fact, what I mean in this case is my 1, let me write that as 9 to the 0. Therefore, I get x is equal to 0. Right, 9 to the 0 is 1. So instead of writing just a 1, I replace my 1 with 9 to the 0 because anything to the 0 powered is 1. I wanted to have 9 to the 0 because I wanted my bases to be identical. Now that my bases are the same, let the exponent equal each other. I'm going to say this is 0. So every time we have a 1 over here, let me give you guys a rule. Every time we have a 1 right there, doesn't matter which base it is, I'm just going to let this equal to 0. So here I have a base of 0.2. I have log base 0.2 of 1. Now, because this one right here, I'm just going to say this is equal to 0. Now, here I want you guys to copy. Remember, I have a few examples where those repeat. Those are exactly the same thing. I have a few other examples where I have a 1 there. So I want you guys to understand on logs, the special cases. So that's basically what you guys will be getting. Now, I want you guys to understand the graphs, though. One thing about the graphs, I can come out with a table. I can come out with a table of x's and y's. So I can rewrite this as y equals log base 2 of x. And I can rewrite this as 2 to the y is equal to x. Since my y is my exponent, I can come out with values of y. So let me create a table of x's and y. Let me fix this a little. Let me come up with a table of x's and y's. Since my y is my exponent, this case I'm going to choose the values of y. I'm going to choose 0, 1, 2. We usually do values of x, the ones we randomly choose, but because my y is my exponent, I'm choosing random values of y. Now, what's my value of x? Right, what's 2 to the 0? That's 1. What's 2 to the 1? That's 2. What's 2 to the 2? That's 4. What's 2 to the 3? That's 8. You see my coordinates there? I can easily come up with points. I can easily graph them. But to be honest, my graph will end up looking like this. That's how my graph would look. Because look, I have the point there. 1, 0, 2, 1, 4, 2, 8, 3. Right? I can continue. So I want you guys to see this. When my base, the base is more than 1, in this case 2, when the base is more than 1, look, my graph is going to be going as if it's going up. One important point I want you guys to see, though, it crosses the point 1, 0. So now on here, look at my base. My base is more than 1. So you have a good idea how it looks like. And you guys have the idea that it's going to cross the point 1, 0. Let me show you how the graph actually looks like. It crosses the point 1, 0. And look, it looks like it's going up. It's going up at a smaller pace than my previous picture. Remember how this one was going faster? Now, the reason why is because the base 10 is bigger. So the bigger the base, the slower it goes up, but it goes up. Just want us to remember that when my base is more than 1, my graph is going to be going up, and it crosses the point 1, 0. Now, what would I do if my base, let me come up with a graph paper there. So what if my base was less than 1? Still a positive number because I cannot deal with negative bases. But what if my base was between 0 and 1? All right, so I can write this. I can rewrite this first of all as y equals, x is y equals logarithm base 1 half of x. So I can rewrite this as 1 half to the y powered is equal to x. So I'm going to create a tables of x's and y values. Now, because of my fraction, I'm going to think of negative values of y. I can always think of the 0 value of y. That's easy to work with. But let me think of negative values of y. Let me think of -1, -2, -3. I could even do -4. On and on. Let me think of negative values of y. Why? Because the negative side is going to undo the fraction. It does the reciprocal, but isn't that reciprocal 1 half? Isn't that 2 over 1? So that becomes a whole number. Once again, the negative sign on the exponent is going to do the reciprocal of the fraction, which in our case, it becomes a whole number. All right, so what do I mean with that? I'm looking at 1 half to the 0 power, right? Because y equals 0. Anything to the 0 power is 1, so that's easy to work with. Now, what is 1 half to the -1? My negative sign basically undoes the fraction. It does the reciprocal. So I'm looking at this as 2 to the 1 power, which is just 2. 1 half to the -2 is the same thing as 2 to the 2. Notice how my negative, it does the reciprocal of the fraction. So that's why I'm calling 2 to the second. That's 4. 1 half to the -3 is the same thing as 2 to the third. So you see why I chose negative exponents? Because it was undoing my fraction. Now 2 to the third is 8. 1 half to the -4 is the same thing as 2 to the fourth. Now 2 to the fourth is 16. So I can easily plot the point 1, 0. I can plot the point 2, -1. I can plot the point 4, -2. I can plot the point 8, -3. And in this case, I can even plot the point 16, -4. So we have a good idea how the graph looks like. Notice how now my base is less than 1, right? Still positive, so I cannot deal with negative bases. But my base is less than 1. So look, my graph is going down. Looking at this one, my base is less than 1. So you would expect it to look like that. You can come out with the tables of x's and y values. I would recommend negative values of y because the negative will undo the fraction. And one thing I want us to see as well is, look, it crosses the point 1, 0. Okay, so we have a rule. When my base, the graph always crosses the point 1, 0, which we saw it in all of my cases. When the base is more than 1, the graph rises from left to right. It looked like it was going up. When my base is in between 0 and 1, the graph falls from left to right. So it looked like it was going down. The graph approaches the y-axis but never touches it. In neither of my cases it reached it. It got close to it, yet it never touched it. So my domain is from 0 to infinity, because how far left does it go? It gets close to 0, right? It gets close to the y-axis, never touches it. And how far right does it go? it goes to the right forever. Now my range is how low does it go? All the way down to negative infinity. How high does it go? All the way up to positive infinity.